My dear students, today I am with another NEET concept, that is energy density of an electric field. And you know, we have a term that is 1 by 2 epsilon naught, that is permeability of vacuum, multiplied by the electric field E, the square of the electric field. This term represents the energy density of electric field. So today we are going to derive its dimensional formula and we'll check the another ratio, that is 1 by 2 B square. B here represents the magnetic field, divided by the nu naught, that is the permeability of space or vacuum. So this energy density of an electric field has its dimensions similar to that of 1 by 2 B square, that is magnetic field square, divided by the permeability of vacuum. So let us check all these things one by one. As you know, energy density of electric field is represented by 1 by 2 epsilon naught E square. So this term here, the whole term represents the energy density of an electric field. So it is energy density of electric field, Okay. As you know, energy density, it is the energy per unit volume. Therefore, we can derive its dimensional formula, or simply the dimensions, in a very simple manner, just equating this as, since we know what this 1 by 2 epsilon naught E square has dimensions similar to that of the energy per unit volume. Why? Because this represents the energy density. So this whole term represents the energy density of electric field. Therefore, obviously it is equal to energy per unit volume. Now it is equal to the dimensional formula of energy. Already, dear students, you know this thing. It is mL square T minus 2 divided by volume. So volume has the dimensions L cube. Now it is equal to mL square T minus 2. Shifting this L cube to the numerator, it is L minus 3. So the dimensional formula of this energy density is M. It is L square L minus 3, so it is L2 minus 3, as LL bases are same, powers are added. So T raised power minus 2. So it is equal to M2 minus 3, it is L raised power minus 1, T raised power minus 2. This is the dimensional formula of this 1 by 2 epsilon E square in a very shortcut manner. So this term represents the energy density, that is energy per unit volume. So its dimensional formula is M L raised power minus 1 T raised power minus 2. And obviously you can check here the dimensions of this energy density are 1 minus 1 minus 2. So these are the dimensions, and this represents the dimensional formula. You can confirm this dimensional formula by using the long cut method as well. So this is the shortcut method which you people use in the NEET exam. So if you are going to confirm this, that whether this term has the dimension as M L raised power minus 1, T raised power minus 2. Now you can confirm or you can verify the correctness of this dimensional formula by following the long cut method. So the long cut method is this. From Coulomb's law, as you know, this is the law which gives you the force of interaction between the 2 point charges. F is equal to 1 divided by 4 pi epsilon naught, okay, Q1, Q2 divided by R square. So, therefore, epsilon naught is equal to 1 by 4 pi F Q1, Q2 divided by R square. So, the dimensional formula for epsilon naught is simply you can calculate it from here. 1 by 4 pi constant, so constants are dimensionless. Here it is the charge Q1. Charge has a dimension AT. Another charge Q2, so its dimensions are AT divided by R square. So R square is L square, length square. And the force F, as you know, the dimensional formula for force is MLT minus 2. So we can write it in this way. The force has dimensional formula MLT minus 2 and R square, it is length square, so its dimensional formula is L square. So therefore epsilon naught, it is equal to A into H is A square T square divided by here it is M, L into L square, here it is L cube T minus 2. Now shifting this denominator to the numerator, it is A square T square. Shifting this M from denominator to numerator, it is M raised power minus 1. It is L cube, it is L raised power minus 3. It is T raised power minus 2, so it becomes T raised power plus 2. Okay, so therefore the dimensional formula of epsilon naught, that is permittivity of space or vacuum, it is M raised power minus 1. Okay, L raised power minus 3. T square, bases are same power side, so it is T raised power 4, A square. So this is the dimensional formula of permittivity of vacuum or the permittivity of space. Again, M raised power minus 1, L raised power minus 3, T square is T4 and A square. And obviously the dimensions are minus 1, minus 3, 4, 2. So these are the dimensions of this permittivity of vacuum. Okay. Now another parameter that we need here is E. E represents electric field, and obviously you know the electric field is defined as the force experienced by a charge. So I will write here. Also we know electric field is force experienced by a charge. So obviously it is dimensional formula. Again, E is equal to the dimensional formula of the force, it is MLT minus 2 divided by the dimensional formula of Q. So the Q is charge, its dimensional formula is AT. So the dimensional formula of electric field is MLT minus 2. Now shifting the denominator to the numerator, it is A raised power minus 1, T raised power minus 1. So E is equal to M L T minus 2, T minus 1. So basically it is T raised power minus 3, A raised power minus 1. So this is the dimensional formula of electric field. And obviously the dimensions are here. The power of M is 1, the power of L is 1, the power of T is minus 3, and the power of A is minus 1. So these are the dimensions of this electric field. Now using this epsilon naught and the dimensional formula of epsilon naught and the dimensional formula of electric field, we can confirm the dimensions of this energy density again. So therefore I can write here for term 1 by 2 epsilon naught E square. Okay, it is equal to, now 1 by 2, you know, it is dimensionless. Epsilon naught has dimensional formula as this: m raised power minus 1, l raised power minus 3, t raised power 4, a square. Okay, into electric field square, so it is square of electric field here. So its dimensional formula is this. So int m lt minus 3 a raised power minus 1 whole square. A raised power minus 1 whole square. Okay. So therefore, the term 1 by 2 epsilon naught E square, that is energy density of electric field. So its dimensional formula is this: m raised power minus 1, l raised power minus 3, t raised power 4, a square into, now here it is m square, okay, then l square, okay, t raised power minus 3, so minus 3 into 2, it is t raised power minus 6. A raised power minus 1 into 2, so it is a raised power minus 2. So it is equal to, now bases are same, powers are added, it is m and m, so it is m raised power minus 1 plus 2. It is l and l here, so it is l raised power minus 3 plus 2. It is d here, it is d here, so it is d raised power 4 minus 6. It is here a raised power 2. So again here a raised power minus 2, 2 minus 2. Now you can check here. It is m raised power minus 2, minus 1 plus 2, it is m raised power 1. Minus 3 plus 2, it is m raised power minus 1. So 4 minus 6, it is d raised power minus 2. A raised power 2 minus 2, it is a raised power 0. Anything raised power 0, you know it is 1. So it is m l raised power minus 1, t raised power minus 2. So again the dimensional formula of this energy density 1 by 2 epsilon naught E square is m l raised power minus 1, t raised power minus 2. Already we deduced this by a shortcut method. So you can verify now. M l raised power minus 1, t raised power minus 2. Here again it is m l raised power minus 1, t raised power minus 2. So this verifies the dimensional formula of energy density of electric field by shortcut method and by long cut method. Okay, fine. Now the question in NEET exam comes also in this way. See, we have this term 1 by 2 epsilon naught electric field E square, that is square of electric field. Its dimensional formula is m l raised power minus 1, t raised power minus 2. Is similar to that of this 1 by 2 b square. B is here the magnetic field, divided by nu naught. So this nu naught here represents the permeability of space or the vacuum. So it is permeability of space or vacuum Okay, so this B here represents the magnetic field. So therefore the energy density of an electric field has its dimensional formula, that is this m l raised power minus 1, t raised power minus 2, which is similar to that of the dimensional formula of this term 1 by 2 b square divided by nu naught. So let us verify this thing as well. So as you know, this is the question which was asked a number of times in the NEET exam. Now, first thing is B, the magnetic field. So we know what from the concept, the force experienced by a moving charge inside a magnetic field is given by, we know the force experienced by a moving charge inside a magnetic field is given by QVB. So this is the maximum force experienced by a moving charge inside a magnetic field, QVB. Okay, so from here we can calculate the dimensional formula of magnetic field. So therefore B, magnetic field, or simply you can call it as magnetic field induction as well, magnetic field induction. So magnetic field or the magnetic field induction has its dimensional formula, which is equal to F divided by QV. Now force has the dimensional formula, that is MLT minus 2. Q, the dimensional formula of charge is AT. Velocity has its dimensional formula LT minus 1. So here we can calculate the dimensional formula of this magnetic field induction or the magnetic field simply. So it is M LT minus 1. Shifting this A to the numerator, it is A raised power minus 1. Shifting this T, so it is T raised power minus 1. Again, you can cancel out here the terms. L and L goes out. So it is now M T minus 2 in the numerator divided by A T and T minus 1 again cancel out here. Bases are same, powers are added. So here we are left with only the A. So shifting this A to the numerator, it is simply now equal to M T raised power minus 2 A raised power minus 1. So this is the dimensional formula of magnetic field induction, or simply the magnetic field. So you can check here. F has dimensional formula of M LT minus 2, Q AT, and velocity is LT minus 1. So L and L here out, T cancels out. We are left with the A, shifting this A to the numerator. So this is the dimensional formula of the what we call the magnetic field induction, or simply the magnetic field. Okay, and the dimensions are 1 minus 2 minus 1. Now looking for the permeability of this vacuum or the space. Again we have, so I can write here, again we know from Biot-Savart's law. From Biot-Savart's law, it is a law which gives you the magnetic field induction at a certain distance due to a current carrying conductor. So we have a Biot-Savart's law. From Biot-Savart's law, the magnetic field, small magnetic field due to a current carrying conductor at a certain distance r, it is equal to nu naught divided by 4 pi I dl sin theta whole divided by r square. So this law we call the Biot-Savart's law. Again, this is in the 12th class syllabus. Biot-Savart's law. So from here we can deduce or simply trace out the dimensional formula of this nu naught, that is the permeability. So therefore, in simple manner we can calculate the dimensional formula of nu naught is 4 pi dB r square divided by IDL sin theta. So now looking for this permeability of vacuum, nu naught, it is equal to 4 pi dimensionless. The dimensional formula of magnetic field is M T minus 2 A raised power minus 1. Already this thing we deduced it. Okay, then R square, so it is L square divided by I, the current, it's represented by A dimensionally, dl, it is L, sin theta dimensionless. So the dimensional formula of nu naught is simply equal to M. Okay, here you can check. This L, 1L and L goes out. So it is m t raised power minus 2, a raised power minus 1, L. So here we are left with a. So giving it to the final shape, it is m t raised power minus 2, a raised power minus 1, L. Shifting this a to the numerator, so it is a raised power minus 1. So therefore the dimensional formula of permeability of vacuum is m L t raised power minus 2. Now a raised power minus 1, a raised power minus 1, it is a raised power minus 2. So this is the dimensional formula of permeability of vacuum. It is mLt minus 2 and a raised power minus 2. So its dimensions are simply 1, 1, minus 2, minus 2. Now looking to this ratio 1 by 2 b square nu naught. Let us check now its dimensional formula. Okay. Now you can see here this 1 by 2 again it is dimensionless b. The dimensional formula of the magnetic field, already you deduced this thing. The dimensional formula of magnetic field is m, already we calculated this, mt minus 2 a raised power minus 1. So whole square divide by nu naught, the permeability. So it has a dimensional formula of m lt minus 2 a raised power minus 2. Now you can check here, it is m square t raised minus 2 into 2. So it is t raised power minus 4. A raised power minus 1 into 2, it is a raised power minus 2. Divide by m lt minus 2 a minus 2. Now you can see here a minus 2 cancels out. The rest parameters in the denominator you can shift them to the numerator. So it is equal to m square t raised power minus 4. Now shifting this m to the numerator, it is m raised power minus 1. Shifting this L, it is L raised power minus 1. Shifting this T, it is T square. So therefore, M and M bases are same, powers are added. It is M2 minus 1. Then L raised power minus 1. Then T raised power minus 4 plus 2. So the dimensional formula is M raised power 1, L raised power minus 1, T raised power minus 2. So again, this ratio 1 by 2 b square nu naught has the dimensional formula similar to that of energy density of electric field. That is m L raised power minus 1 T raised power minus 2. Again here, the dimensional formula is same. So it is m L raised power minus 1 T raised power minus 2. Again, you can check the dimensions are 1 minus 1 minus 2. So energy density has dimensions 1 minus 1 minus 2. Which are similar to that of this ratio, that is 1 by 2 b square nu naught. So what we conclude here from the NEET point of view, we conclude that the dimensional formula, keep this thing in mind because this is the repetitive question of NEET exam. It is 1 by 2 epsilon naught E square. So it has dimensional formula m L raised power minus 1 T raised power minus 2. As we verify it by both shortcut and the long cut method. And this 1 by 2 epsilon naught E square has its dimensional formula similar to that of 1 by 2 B square divided by nu naught. Okay. In other words, we can write it as the dimensional formula of 1 by 2 epsilon naught E square is equal to 1 by 2 B square divided by nu naught, which is equal to m L raised power minus 1 T raised power minus 2. So dimensionally they are equivalent. Okay. So this is what we conclude from this discussion. As has this energy density 1 by 2 epsilon naught E square has same dimensions to that of 1 by 2 B square mu naught. Rest inshallah in the next lecture.